Okay, in this video, I am going to demonstrate the calculus technique of related rates and solve the following problem. So let me state the problem first. So suppose that for a company manufacturing flash drives, the cost and revenue equations are given by cost equals 5,000 plus 2 times x, so 5,000 of fixed costs and $2 dollars per unit cost, and then revenues equals 10x minus 0.001x squared, where the production in 1 week is x flash drives. So let's say production is increasing at a rate of 500 flash drives per week. When the production is 2,000 flash drives, we want to find the rate of increase in both cost and revenue. The way I think about related rates problems is I sit down and say to myself, what do I want to know? And then I say to myself, what do I know? And then I try to get to the what do I want to know, answering those questions using what I know. So first off, we're trying to find the rate of increase in both cost and revenue. So that's a change of cost over time per week and change in revenues per week. So we want to find dc dt and dr dt. Okay, and what do we know? We know that production is 2,000 flash drives, and we know that production is increasing again over time, so dx dt equals 500. So we're increasing production at 500 flash drives per week. I also know my cost equation. Cost equals 5,000 plus 2x, and I know my revenue equation. Revenue is 10x minus 0.001 x squared. Okay, in this problem, we're trying to find dc dt at this particular point in time. So we need to take a derivative implicitly. So dc dt is equal to, the derivative of 5,000 is 0, and the derivative of x is dx dt, so we end up with 2 times dx dt. And dr dt, the rate of increase of revenues, or the rate of change of revenues, is equal to 10 times dx dt minus 0.002x times dx dt. Now it's at this point where I tend to step back and say, do I have enough information? And I look at my equations, dc dt. In order to find dc dt, I need dx dt. And in fact, I know dx dt is 500. And then in order to find dr dt, I need to know dx dt, I need to know x, and then I need to know dx dt. And again, I have all of that information, so I can calculate. So dc dt is equal to 2 times 500 equals $1,000. So my costs are increasing at $1,000 per week. My revenues, on the other hand, are changing. Let's see, 10 times dx dt, so that's 10 times 500, minus 0.002 times x, x was 2,000, times 2,000, times dx dt, which again is 500. So that is 5,000 minus 0.002 times 2,000 is 4. 4 times 500 is 2,000. So 5,000 minus 2,000 is $3,000 per week. So this is a pretty good thing for this company to be doing. Their costs are increasing at $1,000 per week. Their revenues, on the other hand, are increasing at $3,000 per week. And therefore their profits, again, we could write profits equals revenue minus cost. Therefore, dp dt equals dr dt minus dc dt equals 3,000 minus 1,000. Their profits are increasing at $2,000 per week. And so we've solved our related rates problem. Remember, if we go all the way back, we sat down, we said, what are we trying to find out? We're trying to find out dc dt and dr dt. What do we know? We knew 2,000 flash drives that we're making right now. We're increasing production at 500 units per week. We have the equations for cost and revenue. We then, because we're interested in the derivatives, we took the derivative of cost with respect to time and the derivative of revenue with respect to time. We sat down and said, do we know enough information to answer our question? In this case, the answer was yes, and so we plugged our numbers in. If it had turned out the answer was no, we would have had to do a little more work.